Right here we got, this is just examples, right? I mean, I see maybe one of those, maybe not even one that I could factor. No, one of them I could, maybe a couple. But it says we got rational expressions, okay? So this is the most common one that you may be familiar with. Others of this type, like 1/2 or 3/4, these are rational expressions. Fractions are rational expressions. So rational just means that you could take a number and change it into a fraction. So the number 8 would be a fraction, or I'm sorry, be rational because you can change it into a fraction of 8/1, fraction. Okay, so you see all these actually are fractions. That's what this is saying. You got a rational expression, you can make a fraction out of it. It's just sometimes they don't look like this. Sometimes it's, you got some letters, some variables in your fraction. Sometimes you got, well, I guess a couple variables. You could have more than this though, all right? And then, well, what do you do? Because, for example, we've seen fractions before, like 1/2, it's possible you could write it as 2/4 or 3/6 and so forth, okay? This pattern can continue forever. But of all of those fractions, 1/2 would be considered the most simplified. Okay, so when we see these fractions or rational expressions, we need to be able to simplify them, and that's where that factoring stuff comes into play. Functions, just functions as fractions, because it's got the word rational in it, which is just kind of a math way to say fraction. And well, in the past we know fractions themselves, just regular fractions, they can destroy people's lives. But now when we see these types, I mean, it's destroyed before you even get started sometimes, okay? But don't be intimidated by this. Even this one right here, we could simplify that. I think we will eventually, but keep that in mind. Don't worry about the whole fraction right here. Focus on one part at a time, factor that out, and then go back and see what it looks like as a factored fraction. Because once it's factored, you may notice some things. So we can say, yeah, so we're simplifying these rational expressions. Just remember that anything divided by itself is 1, yeah, by factoring the numerator and denominator and removing factors of 1. So it says factors of 1. So we're going to make these phantom ones. So remember, if, let's say that I had 1/2, okay, so we're going to go something pretty familiar, but I wanted a new fraction. So what I could do with 1/2 is and this goes way back, but you could say, you know what, I want a denominator of 6 right here. Well, how did you get that? Well, you'd have to take 2 times 3 to get the 6, but in order for the fraction to be an equivalent fraction, which is important, that's what the equal sign is right there, you'd have to multiply the numerator by the same thing, 3, and then you'd get 3/6. Okay? Now, what this means as well, so I'm going to use it, that was an example right there of, this is scaling it up, but finding an equivalent fraction. But if you start with something that can be simplified, so there's a new example, I guess let's go with 12/16. Okay, so you'll see that this is actually pretty familiar. What you could do, and I'm purposely relating this to prime factorization, okay, for the purpose of the rational expressions. I think some of you could do this in your head. You're like, I could simplify that in my head, and that's great. But again, I'm doing it with prime factorization because it's related to the rational expression stuff. So 12 would have been 2 times 2 times 3. 16 would have been 2 times 2 times 2 times 2, like this, okay? Now it says up here, you can remove factors of 1. Essentially, we're making these phantom ones, right? So in other words, 2 divided by 2 is 1, and that's a 1. I didn't just cross it out. I crossed it out with a 1, so I know I can make that a phantom 1, right? And same with this 2 divided by 2. It's just a different color, but it's a 1. And then if I wanted to, I could rewrite the fraction. I'm purposely keeping these prime factors separated. In the numerator, you had a 3 left over. In the denominator, you had a 2 times 2 left over, okay? So you've seen this before, hopefully. Maybe not very recently, but you've seen it before. And just keep in mind that Sometimes you can factor these out instead of these being 2's. Let's change this. What you could see is that maybe it's a binomial, okay? So, for example, you could have had 2 times, let's do x minus 9, and then it could have been over just x minus 9, right? Well, anything divided by itself is 1, which we've seen. So I could say x minus 9 divided by x minus 9. I can cross that out with a 1 and then ignore it, and then what's the simplified form here? It's 2. All right? So now, instead of just getting rid of these as phantom 1s, we can get rid of binomials and trinomials and things. If they match, we can get rid of them like that. So if you can understand that, again, you do have to get to the factoring point, right? Like, this won't come like this usually. It may start out like this just to help us get started. But usually you have to force it to be factored, and then you'll notice, oh, there's a x minus 9 in the numerator and denominator. Boom. I can get rid of that garbage. Hopefully when you do, you feel good about it. All right, now we're getting into the simplification, right? You have to be able to factor. You have to be able to factor these, not just the binomial in the numerator, but the trinomial in the denominator. It's not asking about the domain, though. So do your domain stuff. Those are different problems. You're going to have to do it, though. This one, we could still declare the domain, which maybe I'll do just kind of quickly at the end. But we need to be able to factor these, okay? So don't get caught up in the full fraction, which is usually what destroys people's lives about fractions. Focus on just one part of the fraction at a time, numerator or denominator first. I tend to focus on just the numerator first. So when I do these, I'm going to do the numerator, then the denominator. Some students are like, I really want to do the denominator. Go ahead. You're going to get the same stuff I am, I hope, anyways, okay? So on this one, well, it is beneficial to have all the factoring stuff memorized, but I'm going to do the work below because I don't have any space above. But 4x squared minus 9, right? This looks to me like the 4 and the 9 are perfect squares. They are. The reason why I'm pointing that out is because I now am looking at a difference of squares. And so what does this mean? Well,
we can ignore the top.
Yeah, since I'm simplifying now I do need to focus on that numerator. Yeah, thank you. So I see right here that my first term in it, and it's subtraction, right? So I am expecting this to break up into 2 separate binomials, one with subtraction, one with addition. But I see that the 4x squared, it would have been a 2x squared, and then the 9 would have been a 3 squared, right? So I now have 2x squared minus 3, but also 2x squared plus 3. All right, and that is my, oh, not the squared, I apologize. I put too much in there. 2x minus 3 times 2x plus 3. That is my factored numerator. So again, that's why I kind of like to focus on just one part at a time. My numerator now is showing as 2x minus 3, and then also 2x plus 3. That's my numerator. Well, what the crap does that mean? You just factored the 4x squared minus 9. That's true. But I don't care about what's going to happen. Maybe nothing happens after that. But in order for us to know that something's going to happen, we now have to look at the denominator, 4x squared plus 12x plus 9, and see if this can also be factored. And it can. That's great news. Because I see the 4x squared, again, that would have, well, I suppose not so surprisingly, but that would have been like 2x to the power of 2, and then 9 is a 3 to the power of 2. So this is going to, it looks like going to be a perfect square trinomial. But we got to check, right? The 12x is that 2 times the a, which was 2x, times the c, which was 3. 2 times 2 times 3, yeah, that would have been a 12x. So this is going to work. It's going to be 1, well, we usually would write it like this, right? And I see the plus sign right there, so I'm expecting a plus between the two values of 2x and 3. It's likely that you're going to want to see this not with an exponent, meaning that you're going to want to expand it from the exponent, so that'd be 2x plus 3. I can do better 3 most of the time, but twice, right? Multiplied by itself. So now that's as much as I can see that I can factor that denominator. So I'm going to go back up here and going to write it in my actual fraction. So I got 2x plus 3, and then times 2x plus 3. And hopefully we notice, so at this point, okay, this is new to us. Let's just sit back, relax a little bit, look at what we've done. We can feel good about it. We've done it correctly. If you've done it with factoring by grouping, you've done more work, and hopefully that makes you feel good inside. But math usually doesn't. So we look at this and we see, all right, well, what do we do with this now? Well, like I said, we look for anything that we can divide by itself. It's just, it's not kind of like what we're used to with the fraction stuff. Because now the factors that we're going to be taking out as phantom ones are binomials. For example, right here I have this 2x plus 3 in red, and I'm going to pair it up with the one directly beneath it, 2x plus 3. That means that, and you could separate it if you really wanted to, but that's a lot more writing, I hope, than anyone really wants to do. It's 1. Okay, now that green one that I just put in there, I'm going to make it a phantom one. What the crap you mean, Sal? It means that I'm going to take the other two binomials, so I still had the 2x minus 3 in the numerator. And in the denominator, I had the 2x plus 3, the other 2x plus 3, I should say. Now, I could show this as times by 1 right there. I just don't want to, because that would make me feel icky inside being a math nerd, okay? So we look at this and say, oh, I feel even better than I did before, even if I used factoring by grouping. And yes, I'm putting words into your mouth, but we look at these two and we say, can I factor these out anymore? We cannot. It is done. Now, of course, we would ask, it's possible it may say something like, well, what about the domain? Well, we know, and I'm skipping some steps here, x could not equal a negative 3/2, not just once, but twice. So that's the domain. I also assume you don't care, but eventually I suppose it may ask not just for the simplified expression, but also for the domain, which we've done. So this is a common error that we see on tests and assignments and quizzes. Not that we have quizzes here, but some students say, look at my 2x's right there. Those, I can simplify those, right? I could say, look, I'm just going to make these a phantom 1. You cannot, because they're part of a binomial together. In fact, I took away the parentheses just because it makes it look pretty to me, but if it helps to see it like this, you can only simplify factors, not individual terms by themselves. Now, I suppose there are ways you could do it, but I'm not going to show it because it wouldn't help. It actually would not be able to simplify still. So yes, do not simplify those 2x's. This is the final answer right there. Or even that some students say, well, the 3's even. I could simplify those. No, yeah, you can't do that.